Hi, good morning. Welcome to the fourth lecture of History of Architecture and Structural Design, Form and Space. Today we're going to talk about iron, steel and networks. So I hope you can learn something about it and have fun to it. Yes, just let me give you a brief summary of what we talked about so far. Yes, we talked about ancient Greek architecture, about structures, columns, beams, spaces in between the columns, as we see it now in the Valerio Ogliatti contribution to the Biennale of Architecture in Venice. And we talked about walls, arcs and domes in the Roman architecture, about walls or not walls, about roofs or no roofs. Yes, and we talked about the Gothic architecture, transparency, and the light coming in, the resolution of the wall, the disappearance of the wall. Yes, and then we talked about domes in the history of architecture all over the world. We've been in Rome and we saw half bowls and bowls in Byzantine and in Istanbul, and we saw the challenge to achieve the diameter again, and constructions in parabolic architecture. We talked about hexagons, 5 angles, triangles, about materials and revolutions in architecture, and we talked about private skies with utopian character, and so that was a very brief summary. Sorry for that. Yes, and today's lecture will be about iron, steel structures and networks. This slide we saw already when we talked about Gottfried Semper and his theories on architecture, but the building where the World Exhibition took place and where he contributed some designs for some special exhibitions is also very interesting, and it's very important for this theme we're talking about today. Yes, iron was a very new material in the center of the 19th century, and it was not used in buildings before, but for greenhouses. And the architect Joseph Paxton, who designed the exhibition hall, was not an architect, he was a gardener. And as a gardener, he knew that the plants need enough light, so he was seeking for a construction or for a possibility to bring light into a building and give shelter to the plants at the same time. Remembering the principles of Gothic architecture, you might say, why didn't he use the Gothic architecture for that, with a high transparency and, so to speak, the resolution, the disappearing of the wall? And if you take a look to some greenhouses from that time, you will find some applications of Gothic architecture, but here it is another task the building has to fulfill. It is an exhibition building, and so the light is very much important to get in, and it was the idea of a very offensive production of the building. In these pictures you can see that they used prefabricated elements, and they constructed them on the site. And they used, so to speak, small cars to move and to lay the small elements very effective. You see this in the picture down on the right. So just coming back to Gottfried Semper, I think you remember his words that he says he's not very satisfied because the transparency is, so to speak, negating the limit of space. So the space is transparent, the light comes in and you can't feel the wall, where the wall is. So this is something we have to come back in the later lecture. Let me give you some more information about the material, the new material of iron. You might say, why don't they use, for example, Gothic elements with these small bricks and the high transparency we saw in the Gothic buildings, or why don't they use wood? Iron and later steel is a very slim material, and you can achieve a very much differentiated construction. Steel is perfect to cover tensile loads and bad for pressure loads. It's not absolutely, but in tendency. So you can use steel or iron for pressure loads, but it's optimized to cover tensile loads. And these this character of the material made a real revolution in buildings. So there were you can think about new buildings at all. I think this was a good reason to choose these materials for this Crystal Palace as the center of the World Exhibition in 1851, and steel will play an important role in other world exhibitions, for example in Paris in the late 19th century with the very famous Eiffel Tower. We will come back to this later, but let me first get more into this principle of steel construction. Well, here you see some pictures with the construction of this very huge bridge, Firth of Forth, Queensferry in Scotland, 1882 to 1889, constructed and built by the engineers John Fowler and Benjamin Baker. And when you remember that the diameter, for example, of the Pantheon is about, let's say, around 40 meters, then you can see that to span or travel longer distance with a minimum of material Forth of Face spans more than 521 meters. So you see there is a really big step of that. And if you look carefully at the picture in the middle, you see the two guys on the right and on the left. They're sitting, and with their weight they can lift up the guy in the middle. So that is the principle. You have the pressure loads and you have used the tensile load, and then you can lift up in the middle and span over a huge distance of space. So what does this mean for space, and what does this mean for architecture? Because in this particular case we have some technical issues, and what does it mean for space and for architecture? Of course, you can span longer distances. You have less heavy and more light material. You have more transparency. We talked about that. We have more light, so you can build much bigger bridges, towers, big statues, for example. You have plenty of opportunities for new kind of buildings, and we have to think that this happens in a time, in an epoch when the industrial development demands for new tasks. We have the bridges for the railroads, we have stations, but we have also other kind of buildings, and I will show you some examples in the further slides. Yes, the bridges, they were very important for the railroad tracks, especially, but we can also see the Eiffel Tower on the right hand in the upper row of pictures. In the lower row you see the Statue of Liberty in New York, which was designed by the same engineer by Gustave Eiffel. And of course, you see industrial buildings for the coal mines, for water towers, for something like that. So the material comes back to its origin, so to speak, and helps to get them all. But there were also other buildings like the greenhouses, we talked about that, exhibition halls, and palm houses, buildings for leisure, for Luna parks, and all these kind of things we see in these times in the century. Architects use that materials to design libraries in a new kind of construction. We have galleries, passages, department stores, and market halls. Perhaps you remember the halls of Paris, Les Halles, which you can see on the right-hand side in the middle of the pictures. And last but not least, stations, all kind of things you need to construct the railroad tracks. So the new material was very good to place in for uses where you need a lot of light. So for example, in libraries to read, in surgery rooms in hospitals, or in photo studios in winter gardens, and so. So the transparency of the material, the lightness of this material, and the way that you can prefabricate it were some very plus points for it. So this altogether makes a big revolution in architecture and in the construction. And we talked a lot about Germany or Western Europe, but if you take a look at Russia at that time, the Soviet Union, and you see, for example, the engineer Vladimir Zhukov, who constructed these kind of pylons for the electric light, for the electric supply. But Zhukov not only constructed power electric towers, but also the roof for the very famous department store GUM in Moscow. The architect was Alexander Pomerantsov, and it was built in the year 1893. And as you can see, it is the outside became an inside because of this very interesting roof, and so the outside, the street is, so to speak, covered, and this was the date of birth for some special passages and galleries in, I think, all of the important towns at that year in Russia, in the east, or in London and Paris also, but also in Northern America or in Italy. You have these galleries, and you can still find them there. It is a very interesting thing that you see the outside facades are walls in the inside room. So the material renews architecture. It is a material and an architectural revolution that took place with the new material of iron, especially with the new material of steel. And the engineers seems to replace architects. So they can construct by themselves, and they build by themselves. So we have to ask ourselves, what does that mean for architecture in principle? So the question should be, what does it mean for space? We have more light, we have less space limitations. Just remember Semper's critique on and his architectural theories. What he was criticizing the Crystal Palace, but he says there is less space limitation. and you can cover very huge areas. You have another feeling from inside to outside. Outside walls became inside walls because you have a light roof of steel and glass on top. But let me show you another element of steel construction. The steel construction is made possible because you use very huge knots, and if you use these knots you can expand the construction over very huge distances. And one guy who was a very good pioneer was the architect Konrad Wachsmann. So he thought about these possibilities. And yes, and there was another guy, Max Mehringhausen, who designed the Mero knot. The idea of both is to work with standardized elements and knots to create a system of construction. And if you look carefully at this slide, you can see on the right something that looks strange. It is a photograph by Konrad Wachsmann. He's a talented photographer as well, and he took a photo of fisher nets which were hanged to dry, and he saw some special system construction maybe, or something, a limit of space or something else. So I think this is something of his pioneer feeling, that he wants to establish also these kind of things into the way of construction. Buchalter Sumi architects established a small exhibition on the Biennale, 16th Biennale of Architecture in Venice, to honor Konrad Wachsmann and his ideas of space. They call it the grapevine structures, and the project of DNA of space. So we are back in the topic of space. It is important to combine the structures, these knots, etc. They became a toolbox to create space finally. And let me give you a very contemporary example, the Fair of Leipzig, designed by the architects von Garkan, Mark and Partner, with Ian Ritchie as engineer, and they used the system what was once constructed by Max Mehringhausen, the so-called Mero knot. But let me remember also the planetarium, the Zeiss Planetarium in Jena, 1926, with its steel grid, and the concrete was later sprayed on this grid, but the primary construction is the construction out of steel and elements in this kind of network, which produced the dome for the planetarium. And that brings us again to Richard Buckminster Fuller, Bucky Buckminster Fuller. And we had already this example of the BFM Pavilion and the World Exhibition in Montreal in 1964. It is a structure out of systematic structure with triangles and knots, and he covered this structure with acrylic glass, and well, today only the structure exists. Well, the new freedom you get by using this material of steel and later of steel concrete inspired a lot of architects, especially in the 1920s, to rethink architecture in general. And let me give you first the example of Ludwig Mies van der Rohe. And there is very recently is a graphic novel published, which I took these pictures from. And if you like to go deep and very fast deep in this issue, it's recommended to read this graphic novel. Well, Mies, Ludwig Mies, with what was his original name, he gave himself the name van der Rohe after the name of his mother, Rohe. So, and the van der is something he added it as his name, and at least he was called Ludwig Mies van der Rohe. So also Ludwig Mies did not only build with steel, and he started with brick. Originally he started with classicistic architecture, neoclassicistic architecture, but his idea was to develop a new kind of space. He's calls it the floating space. Well, it's a strange word of it, but that means that you can come from one space to another space without a physical limitation. And this is something which is the high point of transparency. You walk through, let's say, different atmospheres and different spaces of light and with walls. You can see it at the ground plan. He is declaring his architecture with the ground plan on this picture you see. Well, it's very difficult to identify this ground plan as a ground plan of a building, but it's the plan of the building you see on the picture on the left. It's the cottage in brick, and the interesting thing of it are the holes of it, and the inside voids, the inside holes are not that important, but the outside walls are important because you have to find a limit, something that makes the border between the inside and the outside, and this should be a window, a glass element. And in this particular case, it's very interesting to take a look at the Barcelona pavilion Mies van der Rohe designed for the World Exhibition in Barcelona in the year 1929. See in the ground plan that he's defining the organization, the inner organization of this building with a very few elements, with some walls covered with marble, and with the openings, which are huge windows. You can see it on the picture down on the right side. You can see how he constructed the windows and the limits from the inner space and the outer space. And his idea is that this space has not a very strict limit, a very strict wall. The wall. So he is working again on the resolution of the disappearing of walls. Another very famous building Mies van der Rohe designed was the new National Gallery in Berlin. He had to leave Germany in the year 1938, but he lived further on in the United States, but he came back to design this gallery in the 1960s. Well, this building was originally designed at the headquarters of the Bacardi rum company in Cuba, but so he put this design and took this design and put it in Berlin. But in Berlin, you have the building on top, and you have another part of the building is under the earth, in a cellar, so to speak. So the gallery rooms were in the basement and also on top. And if you look carefully, it might remind you to what we talked about the Greek ancient architecture. You have a grid of roof, you have pillars, you have columns around, and some people say this is really a temple of culture, a temple of art. And if you take a careful look at the wall, you can see that the wall is completely made of glass, and that means that the wall completely, so to speak, disappears. You have no limit between the inside and the outside from the visual point of view. You can't see any limit, but you can feel it. And this is something that declares Mies van der Rohe as a space, a limit, as a subject of architecture. Well, the British architect David Chipperfield refurbished, or let's say better, reenacted the Neue Nationalgalerie in Berlin in the last 9 years, so it's really recommended to go there and see this old new building. Well, another pioneer of the modern architecture in the 20th century was Pierre Jeanneret, called Le Corbusier, and I give you just a brief information about his work and just one example. The example is the exhibition pavilion in Zurich, which is constructed out of concrete, steel, concrete and steel, and you see very clearly that the primary construction is differentiated from the construction for the rooms, for the spaces, for the exhibition spaces. So also Le Corbusier took the challenge to create with new materials, to find new opportunities, new possibilities, new kind of constructing walls. He's also thinking about the disappearing of the wall to get the outside in and the inside out, which you primarily can see with a big door, which are photographed in the open situation. Another example is the roof. Directly under the roof, you can see it on the pictures in the upper row, that there is just an open space. It's more not a balcony, it's not a terrace, it's part of the building, but it has no walls, so you just have the roof on top, and the limit between the inside and the outside is not really defined. The only thing is you have shelter from rain and from sun. Yes, and also about Le Corbusier and the Zurich Pavilion. There was a graphic novel published in the last year, and I could recommend you, if you try to find an easy step into this story, you might use this graphic novel. You see it on the picture down on the right. Yes, the modern architecture of the 1920s were also very present in Germany, also in Hamburg after the Second World War. A very famous architect, good architect of this period was Bernhard Hermkes. And if you like to make a walk in the Wallanlagen in the Park Planten und Blumen, you can find his greenhouses there, and you can see how he defines transparency and light in architecture in this very beautiful building. If you get inside, you can see how the light is coming in and how the plants are growing. But it is also a very complicated construction. It's a very interesting structure. He has a grid on the top, and the glass elements are hanging on it, and this is by the same way now the weakest point of the construction, because this connection between the glass and the construction is going to be rotten, and it's very difficult to maintain this structure, maintain this architecture, and to reconstruct it or to save it. So go quick and have a look at that building. It's worth, because it's really a nice recommended building. As you can see, I took the picture in winter time, but in summertime, when the leaves are on the trees, the whole building is, so to speak, a little bit covered, and it's not exposing, so it's a little bit hidden, but nevertheless it's very bright inside of it. Well, not far away from this building, there is another very interesting building for our particular case of steel networks. It is the Hamburg Museum, or the Museum of Hamburg History, Museum für Hamburgische Geschichte, which was built in the early 20th century by Fritz Schumacher. Fritz Schumacher was at that time the urban planning director of Hamburg. And von Gerkan, Mark und Partner and Schleich Bergermann and Partner as engineers, they constructed a roof to cover the inner court. And well, it reminds me in a way to the galleries or the department store in Moscow by Vladimir Chukov, but this is a very special construction, steel construction with these networks and the plates. And here you can see that this construction changes an outside room into an inside room. So you still have the character of an inside room, but of an outside room, but it is an inside room. Well, in wintertime it could be a little bit cold, in summertime it could be sort of a little bit warm, but you are safe though. It has a high space, so that you have a special circulation. You can open the roof so that the warm air can get out, but you have a special space in it. Well, this was built in the year 1989. Some years later, the famous architect Norman Foster made a similar construction for the British Museum in London in 1949. Well, the difference between these two roofs, I think, is the system they made it. On one side, Schleich Bergermann and Partner and GMP, they used square, a real network with a rectangular system, and Norman Foster used a triangle system as a basis. Well, he is a popular student of Buckminster Fuller, and I think it's also a replique or a reference to his old master. But the effect of this building is the same. You change the outside space of the British Museum into an inside space. They have more an extended exhibition area where you can exhibit statues, or you have some break, you get into the light during walking through the dark museum. And again, it's something that covers and changes the space. Well, the engineering of this project was made by Happold. Norman Foster was also one of the contributors to this exhibition of the Vatican during the Venice Biennale of Architecture in 2018. He is contributing one of these 10 chapels the Vatican is asking for, and he's using a steel construction, a steel network with nuts, and you can see it on the pictures on the slide. The knot you can see in the middle above, and so it is the primary construction. You see on the picture on the right, you can see the altar back in the light, and yeah, but let us take a look at the wall. You can just see there is maybe no limit from inside to outside. It's an open structure. What his idea is not to leave the structure open, but to plant some plants which are growing and then covering and closing the wall, so that you easily can see that he is differentiating between the structure of the building. Let's say this is the roof and the enclosure, the limit between the spaces. So this enclosure in this particular case, it is not mud or brick or textile, perhaps, if you take the example of a tent, but it should be by grown plants. As we see it in the other example of this, let's say, competition or of this exhibition for the Vatican, this is a proclamation of architecture, and Norman Foster proclaims his architecture, as well as Eduardo Sato de Moura or others in this competition. But it brings us back to something which I find is very important in architecture: the difference between the primary construction of the wall or the facade and what Gottfried Semper calls the enclosure. Well, I don't like to bother you with this guy, but I just want to come back to this issue because we discussed it in the last Q&A again, and I think it is quite interesting, his theory of clothing. And so you see in also in the Norman Foster contribution to this competition that he is differentiating between the primary construction, which is made out of a steel or a steel network, and the enclosure, and the enclosure in this particular case are grown plants. Yes, just let me come back to this photograph taken by Konrad Wachsmann in the early 1930s, so when he had a scholarship at the Villa Massimo, the German Academy of Culture in Rome. He took this picture, and I asked myself, why did he took the picture of these fishermen's nets? And but if you look carefully, you can see that these nets are falling like a parabol formed by. They have a parabol structure indeed. And if you remember the Gothic architecture, where we just have vertical forces in the pointed arcs, or if you remember the dome in Florence, constructed by Filippo Brunelleschi, which is in the section, is also a parabolic architecture. Then you see that this falling is the similar thing than the forces which comes from above. The book where Konrad Wachsmann published these images is called Aspects, and it's a book with photos he took in Rome. I talked about this already. And what makes me wonder is that he just have the most of the pictures are ancient architecture, so he is very keen to show the structure of this ancient architecture. And so you take a look, and then you see how the forces are going and how the architecture is dealing with these forces. So that I think is the context in which this picture is. You have to read this picture. Well, the parabolic arc, the pointed arc in the Gothic or the Arabian, the Arabic or the Ottoman pointed arc, this is an old culture of building. It's an old kind of dealing with these kind of forces to have no horizontal forces, which makes it very much easy to construct. But if you take a look at the nets, it's the other way round. So in a way, you have to fix these the structures, all these things, and if you turn it up so that the bottom is on the top, then you can model, so to speak, these kind of structures. Well, Konrad Wachsmann took these pictures in the 1930s, but from the end of the 19th century there was a guy in Spain or in Catalonia who was experimenting, made experiments with these kind of things, with these kind of structures. His name was Antonio Gaudí, and Antonio Gaudí had a real big project. He wants to construct a cathedral. And if you remember what I told you about the Gothic architecture, these Gothic cathedrals were built over years, decades sometimes. Centuries, not centuries, but decades. And when one architect started the building, he couldn't see the end. So it is, so to speak, a heritage was taken and continued by other generations. So that was it. Was Antonio Gaudí had in mind when he started the design of the Sagrada Familia. And I'm thinking they're still constructing, still building on this cathedral. And his design was made on studies on this model of chain, this chain model. So if you follow the thought I sketched out in the last minute, that you have a parabolic structure, parabolic architecture, and if you put white on the end, then you can just, so to speak, model it in the other direction. The other dimension, what is on the bottom should be on the top. And to read this model, Antonio placed a mirror on the bottom, and if you look in the mirror, then you see it the other way around. And today we have other possibilities, other opportunities, even if you work with a computer like I did. So I just made the trick and turned the pictures on 180 degrees, flipped it in the horizontal, and then you can see on the right how his cathedral should be constructed. So, but if you have doubts on what I'm talking about, then I can recommend you a very simple experiment. Just take a chain, whatever, a piece of jewelry or something else. You take a chain, then you put it to thumb and your finger, and then hold it and let it fall, and then you see it describes a parabol form. And if you put a little white on the bottom, then the form is much more steep. And then you have to imagine that you fix this chain and turn it upside down, or you take a picture and then you flip it into 180 degrees, so the bottom is on the top now. And so then you have the form for an arc, or let's say you can also construct a dome like this. And you also can make an experiment. You link some other chains, and then you come to this model. Yeah, this is a postcard of the Sagrada Familia from the 1990s. But in the meantime, they finished the main room, the main hall of the church. On the left you see the postcard. On the right you see a picture taken from above. Well, it is a little much orientated on the Gothic architecture. You see the same. It's the same basic idea of form and force, but it is a very modern architecture. Antonio Gaudí is more an architect which is classified as an Art Nouveau architect or Jugendstil architect. But on the other hand, this building is, so to speak, timeless, and as you can see there, it is under construction since 1882, more than 140 years nearly. And so it is a timeless building. But Antonio Gaudí did not only build on the Sagrada Familia. He was also very famous for his housings, his villas and apartment houses. For example, this is Casa Milà, House Milà in Barcelona, built between 1906 and 1910. And if you take a look at the wooden construction of the roof, then you can see that he is not only using this principle of parabole arcs for steel or chain structures or steel concrete. This is the material Sagrada Familia is built out of, but also on wooden construction, and it made it possible for him to create very new forms and a very new kind of architecture. So Antonio Gaudí was very famous for his very free and romantic and forms and architecture. So he is it's right that he is called an Art Nouveau or Esprit Nouveau architect in the early 20th century. Some people don't like this architecture because they say it looks like a fairy tale, and it's not being rational, and it's too expensive, and what else. But if you make an experiment, when you like to become a new form, a new architecture, I think you have to spend some ideas, perhaps you have to spend some money to find new forms, to find new kind of spaces and new kind of ideas and new kind of architecture. Yes, just let me end this lecture with this fantastic architecture in the real sense of the word. And remember that fantasy is the product of creativity. That fantasy is always a very important tool to design whatever architecture, construction, structures, or to measure the world. So you always need creativity and fantasy to get on the goals you're setting yourself. Well, you realized maybe that I was came far away from the pure and brute steel construction, but the material steel was responsible for, let's say, revolutionary development in buildings and architecture, and the combination of steel and concrete is something what makes other things possible, which makes other things thinkable. And Antonio Gaudí was a good example for that, about the new forms which are possible when you combine steel and concrete. So the next lecture will be on shells and other forms in this of combination of steel and concrete. So steel is not only the pure thing, but also the combination of different materials and different things, of different views on the kind of building and architecture. So that will bring us give us another aspect of new architecture, new revolutionary architecture, a new kind of living, as architecture is the frame of life.